Here we're going to start with the augmented matrix from the previous video, and we're eventually going to see how we can use this matrix in order to solve the system of equations. However, before we can go straight to solving it, we need to introduce the three things that you are allowed to do to a matrix. These are called the row operations, or sometimes called the elementary row operations. These are the three things you're allowed to do, and you don't want to try to do anything else because you might mess up your problem. And all three of these, the reason why they're allowed is that they will never change what your solution is to your problem. So that means if you do them, you are still going to get the same answer, which is the most important thing that we're trying to do here. So what are these three steps? Well, the first thing that we can do is we can swap two rows. That would correspond to, when writing down your different equations, just changing the order in which you wrote them down on the paper. It's not going to affect what your answer is whether you write one equation as the first one or if you write that equation as the last one. And so here, let's go ahead and give an example where I'm going to take my matrix here and I'm going to swap the first and third rows. Now the notation I'm going to use for that, for swapping rows, first off, if I'm doing any row operation, I'm going to put a big right arrow here. And then if I want to swap rows, I'm going to write R1 double arrow R3. That means I am swapping the third row with the first row. So you see the original first row becomes the new third row and vice versa, and the second row does not change at all. The second thing you're allowed to do is you are allowed to multiply any row you want by any number you want, other than 0. And that corresponds to, let's say you wanted to divide a row by 5, that's multiplying by 1/5. If you wanted to, say, multiply both sides of an equation by 10 to clear out denominators, that's multiplying by 10. So this second row operation just corresponds to multiplying both sides of an equation by a number, which is a perfectly allowed algebra technique. And so let me go ahead this time, and I'm going to take the third row and I'm going to multiply it by 5. So here's what I'm going to do is I'm going to write 5 times row 3, and I just want to tell you where I'm going to put that in. I'm going to put the answer inside row 3. And notice I didn't say anything about row 1 or row 2, so nothing's going to happen to row 1 or row 2. All I'm going to do is I'm going to take everything in row 3 and multiply it by 5. Okay. The last one is going to be the one that we're going to use most often. It is definitely the best rule. It's the one you want to rely on all the time. The only problem is it can be a little confusing at first when you see this here, because I'm going to take my matrix, and what I'm going to do is I'm going to do the following. I'm going to say -3 row 2, add that to row 3, and put the answer in row 3. So here's the confusing part. It says that I'm going to multiply row 2 by -3. However, in my new matrix, your row 2 is going to be the exact same as it was before. Because when we're doing this here, I'm only temporarily multiplying by it before adding it into a different row, and the only row that's going to change here is the row 3. That's the only row that's going to change when you're using this operation. This is one of the reasons why it can be very useful to use this notation. Only time you can have something change is if the row has an arrow pointing into it. That means it can change. Here, the only time something can change when the arrow is pointing into it. Here, both of them have arrows pointing to it, so both of them can change. Now what else am I going to do? I'm going to say, okay, multiply this by -3. -3 times 1 is -3. Add that into here. 3 plus -3 is going to give me a 0. Then multiply -3 times 1, I get -3. Negative 3 plus 2 is negative 1. Multiply negative 3 times 1 is negative 3. Add up negative 2, negative 3 makes negative 5. And multiplying this times negative 3 is, negative 18. And negative 18 plus 1 is negative 17. So these are the only 3 row operations that we have here. These are the only 3 things that you're going to be allowed to do to a matrix. And these are all we're actually going to need in order to solve these systems of equations.